Okay, so now we move on to lecture 8 of the ANSYS Design Modeler training series, covering parameterization. So what is parameterization? Well, parameterization allows us to execute a series of operations repeatedly by changing associated input values. So what we're doing is we're characterizing the most important parts of the geometry and assigning them particular numerical values so that we can then control changes to that geometry just by changing those characteristic values, which are the parameters. Now, the parameters need not be geometric only based parameters. There could be parameters associated with something else, for example flow rates or load values or constraints, anything like this. But in the context of Design Modeler and geometry changes, this is a key area in which parameters can be employed. It can be used for analysing multiple design points by changing the geometry or topology based parameters. So if we wanted to look at lots of different geometric design changes, we could do it directly from parameters if the geometry can indeed be parameterized. We can apply parameters not only to 3D geometry, but they can be applied to sketch dimensions and inputs for plane creations as some examples of the types of operations where parameters can be applied. And parameters can be linked with each other through expressions. So if we say that, for example, the length of a particular geometry has always got to be 4 times its width, we can specify that as a parametric constraint. And also an important point as far as Workbench is that parameters can be transferred across applications within Workbench. So that once we've set up all our parameters, whether they be geometric parameters for Workbench or solver-based parameters as far as the solver is concerned, we can then control all of the design changes from Workbench itself, and we need not go down into the individual applications once they've been already exposed in those particular applications themselves. We can then control the entire simulation at the Workbench level. I mentioned very briefly about geometric and topology based parameters, and here we can see greater distinction between the two different types. So geometric parameters are parameters associated with the existing geometry. So here we can see this example of the cylinder and 4 fins protruding from the periphery of the cylinder. And if we have a geometric parameter associated with the length of these particular fins, and we can simply update the value of this length of the fins, and it will allow Design Modeler to extend the length of these fins. So we need not go into each of these individual fins to extend them. Once the extent or extrusion length has been assigned as a parameter, we can then just change that parameter and they'll all be updated to reflect that. The other type of parameter is the topological or topology based parameter. So here what we're doing is we're not changing the geometry, the existing geometry, we're changing the topology. So here we're adding or subtracting to the existing geometry to create new geometry, to remove geometry. So here's the example of creating a copy or patterning of the fins around the cylinder, and we're changing that number, so it's creating a different number of fins around the perimeter of the cylinder. So here the parameter value would be the number of copies in the pattern feature, which is the Design Modeler operation itself.